everyone. Welcome to the new ones and welcome back to those who have participated in our previous DevOps Artisan webinars. My name is Elena. I'm DevOps Artisan Product Manager. I'm happy that we are here and we hope that at the end of the webinar, you will find the shared knowledge valuable for your work and the development of your understanding. Together with me, with a 20-year career in software development, Narendra Babu will share his practical experience explaining to us in detail concepts like Docker Cgroups, namespace, union file system, how containers use them internally, and much more than that. He will share during the session real use cases and practical demonstration for a better understanding of the concept. But before handing the microphone to Narendra to tell you more about him, I want you to encourage you to ask questions. Even during the demonstrations, Narendra will take them over and try to answer them. Narendra, can you stop a bit?
Perfect.
Please.
Yeah. Can you hear me?
Great. So, as I said, I encourage you to ask questions. Your microphone, please, Narendra.
I'm good. I can hear you.
Okay,
microphone is on.
I need you to stop your microphone for a second.
Oh, stop.
Yeah, thank you. All right, so use the Q&A box with confidence, and if you want to ask questions using the microphone, use the raise hand function, and we will take care to unmute your microphone. So that's it for me. Narendra, the stage is yours.
So hope everybody sees my screen. Yeah. So okay. So I'm Narendra. So good evening, everybody. So today, as Elena mentioned, today I'll be talking about Docker Cgroups and namespaces, and I'll be talking about my experiences and how I use Cgroups and namespaces in my practical projects, how to troubleshoot issues in the Docker world. And I want to just put a disclaimer here saying that this is purely a technical thing, the low-level things, and this is all about the low-level kernel-related things. I'll be talking more on the kernel stuff. I know it's very engineering stuff in the sense, but at least I'll make sure that you understand at the high level and you understand at the lowest level what happens at the kernel level, because the topic itself is Cgroups and namespaces, and these are part of the Linux kernel. And these two things makes the Docker in a real live project kind of things. Docker exists because of these things. And with that one, that's what I want to keep people know that this is purely engineering and technical and the low-level Linux kernel stuff. That is what we are going to talk about, not about what is Docker, how Docker is used in production. Those are different topics. Those are different concepts totally altogether. But this is totally internal. That's what I want to keep it to the audience. What is the expectation? And so to talk about myself, so I'm Narendra. So I'm a CTO of a startup. So previously, I used to work in Bloomberg and BlackRock, one of the largest fintech companies, which is handling $7 trillion worth of asset. And most of my experiences are coming from last 2 decades, plus half of the decade I was in US working for BlackRock, Bloomberg, and Hewlett Packard in Wall Street. So most of my time spent in only fintech companies. So that's what I want to share my experiences on that one. So let's talk about today's agenda, right? So, and you can wait for some time to ask questions. You can post it in the chat, and Elena can stop me and I can answer those questions. Maybe most of the questions will be answered in coming slides kind of thing. So it's your choice, pick your choice. I'm open to answer every kind of question. So about me on the technical side, it's not just a 20 years of experience. I share my experience. What did I do in 20 years in a one-page document? What are my experiences in New York, and how do I and what kind of people I meet, especially the Docker committers, Kubernetes committers. You talk about any technology which is born after 2010, definitely I would have met with those committers, and that's my active participation in the meetups, conferences. That's how we meet people who have actually created these products. That's how you learn, part of the community. And I'll share about that experience also, how you should be part of the community and how you will be keep learning up to date with the community, whatever technology you pick up, Docker to Kubernetes to security to any kind of tools, any kind of technology you work on, you should be part of the community as per 2021. Doesn't go without the community. And we'll talk about Docker internals. So this is what called as Cgroups, namespace, and union file system, and advanced union file system. You can name it overlay file system also. This how these things work towards each other to make Docker a perfect tool for containerization. Without these things, and without these kernel features, Docker doesn't exist. And we talk about a little bit about Docker security because I want to ensure that Docker security is itself, it's a different session, but I'll make sure that one, I'll give you some highlights of what is coming in the future session, especially for Docker security. It itself will take 1 hour of the topic, but I'll give you the highlights. I'll give you some view of what you should need to take care of Docker security in terms of production. That's a very important topic for us. So little bit housekeeping. So one of the things which I always explain to any engineer or anybody who wants to learn some technology or a stack, a tech stack or anything, I will be always looking back where the problem is started, where this innovation has started, this tool has been started, what kind of problem it is solving. That's more important to me rather than somebody says me this is a fancy tool, it solves some container problems. Oh, we are good to go for Kubernetes, scalability is there, high availability is there. But still, I want to be getting convinced that one, am I really having those kind of problems, right? Until I don't understand the problem statement, I will not be much enthusiastic to learn that one. That's one of my core learning for the past 2 decades by working on Unix and Linux. Until I don't understand what is the problem you're solving, that doesn't motivate me. So that's one of the things. Most of my sessions will be on mostly on problem solving, problem statement, why kind of things, rather than what and how you can do. There are tons of YouTube videos, tons of blogs, you can try it out, but why and what is not something. Why, especially the why factor, why is not something everybody explains in a very nice way kind of thing. So until he experience that problem, only those people can explain why. So I have experienced this problem, that's how I can talk about the why thing. And everything is on GitHub, so don't worry about all the examples, all the use cases, and you get much more than an entire Docker lab session itself. In that one, out of 15 lab sessions, I'll be talking only 2 lab sessions. One is with the Cgroups, one is with the security things. So that's there. You can do it at your free time, home, workplace. All the GitHub URLs are already there on the slides. And I'll be using for my lab sessions only Ubuntu 2004. So that's where all my lab sessions are well tested, and that's where IOPS has been integrated into Linux kernel in Ubuntu. That's the first place where Docker was born in a saying. So you can use your GCP, AWS, AKS. If you have Ubuntu 2004 installed, you can run that one seamlessly. I've tested many things, right? And uniquely learning experience. What did I learn from the actual people who created these products, and what did I learn from actually implementing in my company, Bloomberg and BlackRock and Hewlett-Packard, for the last 10 years, and for last 4 to 5 years when I was working with Docker and Kubernetes in the fintech companies. And be patient. As I told, there are many things which will come until the end you get the full experience, because I go step by step. I go 0, 1, 2, 3, 4, 5, not jumping into the 5th stage without understanding 0. So it's a baby steps of understanding. It's an in-depth details. So just be patient. That's what I want to share. So who am I? So at a high level, as Elena has mentioned, 2 decades of experience, and recent past is a Bloomberg, BlackRock, and Hewlett-Packard. And currently I'm a CTO and Chief Architect at a startup, so mostly on the Kubernetes and Docker things which I work on. And I enjoy the experience of software engineer. So I implemented DevOps for BlackRock, end-to-end DevOps for my developers who was having a tech stack, Python, Java, C++. Most of the time C++. That's the core thing where real challenges were there. That's where I implemented, designed and implemented and wrote entire build system, entire CI/CD pipeline for BlackRock. And VP, different roles have done, pre-sales and business development manager. And I love open source. Till 2 decades, I don't know what is commercial products. I have used only open source. And commercial is on the Unix side, but whole Unix/Linux. That's my whole experience. And that's how it is. So everything I talk about, everything is connected to the things which I do in Docker and Kubernetes. If these things are not there in the first place for 2 years, my experience of the Docker and Kubernetes will not be so enthusiastic. Rather than jumping into a new tool and technology, I'll be more enthusiastic about where I started with. And it very very much in line with the learnings what I did. So this is my past experience. I would have worked with, these are 5-6 flavors of Unix. If people know what is Unix, it's a Unix operating system. So that is where Linux was born. It's a derivative for x86, but Unix is being commercial, from HP Unix to Sun, SCO, AIX, from IBM, DEC, Digital. So for every project I got, I was very lucky, and I was very lucky to different Unix platforms. And most of the time, I work only on C++ and the compilers, and most of the time object-oriented at the low-level things. And my experience is on touching the code, which is 10 years back, 20 years back, and adding, refactoring the code. And that's how you dig lots and lots of information from the existing code. Replacing the existing code, writing a new code was never an option for me. I can just enhance, and I ensure that the code works with the new code which I write in Unix and Linux environments actually. So that's where I have experience with a lot of troubleshooting tools. Most of the times I use debuggers, tracers, compilers, linkers. That's my core expertise. I love to optimize at the compiler level. And profilers or debuggers are my, what do you call, shield, or my core expertise on solving somebody's code, not only just my code. It helps me out to figure out the problems. It helps me out to understand what happens behind the scenes. That's what we're going to talk today. And libraries, build systems, DevOps 2.0, which is nothing but Docker, CI/CD, all are in line step by step. And it goes until the Kubernetes, where you deploy your Kubernetes, where you deploy your containers on Kubernetes, which is a container orchestration system. And these are the things which my engineering experiences. When somebody talks about experience, I want to hear these experiences. Okay, what actually you did, what kind of problem you solved, and what can I expect from you when you talk about technology things. So I build my own kernel, and I build my own compilers. And I don't think so I have any time installed in Linux or Unix, right click, install the software. No, I always install by sources. I download sources. I need to, because working in finance, that's one of the core responsibility for me is I cannot take any open source project and just add it to the developers list and ask them developers to deploy applications in production. No, that cannot be happening. So I had to look at the sources. I had to build my sources with the make install, apt-get, yum. Those are only add-on for my testing, but I always use make install, make test, starting from configure, make install. People understand how to build software on C++ environment, because I optimize compilers. As I told, my performance jump will be always 20 to 30% when I do at the build time itself. Any third party, any open source projects, I do like that only, mostly C++ on the side. And I care about core engineering things, very, very important for me. I care everything what happens inside things. I cannot take it for granted, because working for a $7 trillion worth of assets management company, we have to deal with 192 countries regulations, and any mistake I do can screw up many things in production, and we have to pay penalties, and we have to follow lots of rules and regulations. That's one of the core reasons why I should take care of these things. I cannot miss any of these things. This is the responsibility. You need to ensure whatever goes in production, you audit it, you vet it, you test it out, then only it should be going to developers, and then it goes to production. So I was the gatekeeper for these open source libraries, whichever comes to my company. I validate. I care about simplicity, performance, stability, standards. If it is not any of these categories, if it is too much complicated, doesn't follow any standards, doesn't follow any stability, doesn't have any performance, I'll not be much interested to motivate to learn those things. So my core focus is only, and that's what I did for the last 20 years. Any of these things, it should be fit into these categories. However fancy the technology, it's too complicated, very, very painful to learning experience, not much interested. It should be standard. If it is performance, yes, I love to have performance. I love to learn those things. Productivity, yes, that's one of the things. And I love troubleshooting exercises. And I like to be more on CPU and memory side, the low level things, which we are talking in terms of C groups as we go forward, right? And I always want to improve, because there is no such thing called as you learn something, it will be there forever kind of things. You learn, you have to move with the current things. Docker, Kubernetes, everything you talk about on a cloud native environments, the lifetime is just 3 months. After 3 months, things move very faster. People break a lot of things. New releases comes. Even in the demos, I would have used examples which breaks often, because there are a lot of things, moving parts are there, a lot of things changes, a lot of things breaks. So it's not that you can complain about that one. It's all about the faster movement. It's all about, that's the place you need to start. If a command runs perfectly for you, that means that you're not going to learn anything. You just run a command, you learn something, what is an output of that one. But when something breaks, that is where you go and troubleshoot. That is where you go and look at. It's not just cut, copy, cut, copy, paste from a stack overflow and without learning what you're doing. But these are things for Docker, you need to know the internal things. right? And one of the important factor I always tell them is collaboration and work with the community is one of the important factor I learned in States, especially. Without the community, I'll never be here in the first place. Community is a mandatory. You should be part of the community, and I'll tell you how to be part of the community, how to learn from the community. As I told, this is not one technology you learn 10 years you can survive for this one. This is every 3 months, keep on changing, because we have a lot of teams, a lot of innovation happens in cloud native environment. So you need to be keeping up to date. No single person can know everything. So how to be knowing everything? You should be good at how to be part of the community, and I'll share you that experience also. So somebody asked me, how do I start with a Docker? Just to give a heads up on this one. This is where I always advise people that one, don't directly go and jump into the documentation, start about those things. Learn from community. How do you learn from community? Just search in Google awesome Docker. Put anything technology prefix with awesome. You will get that particular technology's full scope of tools, frameworks, libraries, everything in open source community related to particular technology you get in that GitHub project itself. I'll share you that link also in my slides, and I'll tell about what are things you need to take care of in that one. And when you talk about Docker, I always advise people learn a little bit about Linux kernel. It is always helpful because it's a low-level thing. At the high-level end user, you may not be much enthusiastic, but when you write a Docker files, you need to know a little bit about the Linux kernel things, at least a little bit. You need to learn, keep learning things. You have to start something. And the compilers for optimization, that is where you learn about optimizations, and be part of the community. Go to the GitHub, look at the Docker Hub, Docker GitHub URL, and look at the issues, what is happening actively in that community, what kind of issues people are facing. Can you retry it? Can you retest it? Can you reproduce it? And that's how you can contribute to the Docker community. That's how you're actively with the Docker project itself. What is happening in Docker, what people are developing in Docker, what are the new features they're adding, why it is breaking, what could be the reason, so that you can protect yourself in the future production issues. That's how I keep up to date in the Docker world. Security issues, anything which can impact my production. So those are things I keep up to date by looking at the Docker GitHub URLs and all the GitHub related stuff, whichever is related to Docker in terms of, and parallelly it applies for Kubernetes and other tech stack also. And be part of the Slack communities. So that's where I look at what people's problem are facing. Can I try to help them out? Am I facing those problems? Did I solve those problems in my environment? So that's the way you'll be part of the community and attend meetups. So online meetups or offline meetups, please attend those things so that you know from the learnings from other people, technical, what they solve the problems. Because as I told, no one person can know everything. So you have to learn from other people's experiences. That's the community part of this one. Attend online and offline conferences. Wherever you get a chance, go for the Docker conference. And that's where you meet Docker creators, Docker committers. You learn from the latest and greatest from the people. Stack Overflow for the Docker related issues. And this is what I was talking about. These are the URLs you need to keep focused on. This I could have kept it the last slide. I always tell that one. Last slide, people just ignore it. Just, okay, that's just a reference kind of things, but I want to explain why it is in the front slide. Because this is where you need to start. When you talk about the security, you'll be talking about awesome Docker security. That's where you look up all the security related stuff on the Docker side. And there are a ton of material there. That is the source of your truth, not about any blogs. Blogs might be there, but too much confusing, too much noise there. This place is not too much confusing. People are the real engineers who actually create. Those are the people who are actually community here, present here. As I told, local meetups, subject matter experts, and attend the old conference also. Look at what the problems other companies might have solved so that it can help you out to strategize containerization in your environment. Just to give those, and people want to learn from online experiences. People can learn without even actually installing Docker. So this is one of the URLs which you can use it for learning Docker online itself. So let's start with now today's session, right? So before even jumping into Docker, Cgroups, and namespaces, I want to just give a heads up of where it started with, right? So Docker, it's before Docker, containers were there for last 20 to 30 years, actually. It starts from IBM 370C, then HP, Sun Solaris Zones and all. So it's Docker just made it very easy to people, chroot, BSG jails, those are the old kind of things. So Docker was not something which is invented something new. It is just reinvented and made it simplified to the people. And it started with Google experience, because Google are the first people who actually tried containers in production. That time they have their own naming country. They can just say containers for you, right? But in real world, containers were not existing until 2005, 2006. Docker created around 2013 or 2014. That's where Docker came into place. But if Google didn't contribute C groups and namespaces to the Linux kernel, Docker would have never existed. And that's the bottom line why I always focus on Google, because that is where the container started. If you look at any product in Google, starting from Gmail to Maps to YouTube to their Google Earth or Google Photos or any kind of product you think about, everything runs on containers. If you launch a Gmail, think that one, it is launching 5 to 6 Gmail containers to maintain high availability, to fast speed up for actually, if anything goes wrong with one container, it can speed up and spin up other containers. Obviously, it maintains that one. So in a nutshell, even the VMs run in containers, and they launch around billions. Now it is more than billions of containers per week. That's the scalability, billions of containers, right? So whatever the products they talk about, think about every product they use, we use as an end user, it's all behind the scenes is the containers. Containers makes their life easier, and they have their own implementation of that one. Docker made it using those kernel features, C groups and namespaces, to make container in a real usable way kind of things. So containers, in a simple nutshell, containers are a great way to package and run apps. It's a self-contained, low overhead, fast starting, easy to compose, and easy to replace. These are the characteristics which makes containers for scalability, containers for high availability, and more number of containers running on a single host. So this, I always tell people, Docker, very, very important. These containers opens doors for innovation. It's talk about any technology you talk about, function as a service, CI/CD, DevOps, cloud native, portability, scalability, reliability. Everything is tied up some or the other way, microservices, Kubernetes, some or the other way, containers, some or the other way you'll be using containers, irrespective what kind of tech stack you're using it. So it's always important you start learning the low level things, then you go to the next level to understand how things happen. And what are containers? Just to give a highlight things, it depends on who you ask. There are two different representation of containers. One to an infrastructure guy who's an ops guy, one's for a developer. This is an important bifactor. You need to understand differentiating things. You cannot talk to ops guy like a developer. You can't talk to a developer to understand what an ops guy. When you talk about an ops guy, he should be talking about only about the shared kernel, which actually maintains that one. He talks about lighter VMs. He talks about simpler, denser than VMs. In the sense, containers can be, I can fit more containers on a single virtual machine or a single bare metal. And it is portable across different environments. That is for him, QA to development to test environment to production. For ops guy, those things matters. For developer, it's totally a different world. All he thinks about a container is, I can package my dependencies. I can take my baggage. I can take up all my dependencies with my application to dev, TST, production. It can run seamlessly in all the environments because I'm packaging with my environment. See, I'm packaging with my dependencies. So I know what my application needs dependency. I can run independently. I can be started independently. I cannot be interrupted with other people. I can't be intersecting or I can't break or I can't use somebody's resources. And deploy to any environment in seconds. So it's all about how do you manage, and it can be easily accessed and shared across. I can pull the images, other developers, other community can use my Docker container or Docker image in one nutshell, right? That's what to ask for. This is a common example. Everybody talks about it. So you need to understand when they talk about VM to containers, people need to know what is a VM, virtual machine, right? So it's a virtual machine. On a simple hypervisor, I can have multiple virtual machines dedicated with its own operating system, dedicated with its own applications. In a containerized world, you use a shared kernel in the sense, here we talk about a virtual machine, which is nothing but a physical thing, which has a CPU memory allocated to that particular virtual machine. But when you talk about a container level, you talk about much more higher level. It's all about applications you're talking about. You're not talking about machines, but it's a wrong comparison. But that's a way to understand, to make people understand that's what they use virtual machine to containers. This is the important differentiation you need to understand. What's the differences, right? When you talk about a virtual machine and container, VM isolation or a container isolation. That's the first important factor people need to understand. When you talk about a virtual machine, you're talking about a VM isolation. When you talk about the containers, you're talking about a container isolation. Now, when you talk about VM, so why it is a negative? Complete OS, disadvantage, static compute, static memory, high resource usage. So when you spin up a VM on a cloud environment or anything, you need to know before how much memory, how much CPU, what kind of operating system you need to install beforehand itself. Once you assign those memory and CPU limits for your virtual machine, you're not going to change dynamically. You need to shut down the VM, add more memory, more CPU. So that's called as a disaster for high availability kind of things, because you can't increase it. Suppose you dedicated 20 gig of RAM, 64 CPU and 20 gig of RAM. Suppose that VM is not using that one, you're wasting the resources. So you don't have any dynamic change of dynamic change of this memory and CPU limit. So you're wasting memory, you're wasting CPU and memory, and you're wasting power and cooling, and you're making your machine very idle, allocating more resources, not much usage. But on a container level, you can increase, you can decrease your CPU memory. It's a burstable compute, burstable memory. Why? Because it's a very fast to start up containers. That's the reason you can maintain high availability, and it has a low resource usage. That's what we can have billions of containers running on this Google infrastructure. You can have more containers running on a single host or a single VM. Application portability with VM, it's a wrong thing. It's a difficult and challenge. You can't have a single VM ported across a laptop to bare metal to virtualization to private cloud, to public cloud. It's not scalable. It's not even portable. So you have to have specific like Hyper-V, KVM, VirtualBox. So those are different technologies. So you can't have a portability of, I built an application, I deployed in a virtual machine, now I want to migrate to a different environment. That's not possibility with the virtual machine. But with the containers, yes, that's possible. With one container, one image, you can run your Docker container across your laptop, bare metal, Mac, any operating systems which has a Docker daemon running, virtualization, cloud, public cloud, private cloud, irrespective what it is, all it needs is a Docker daemon running. You can run your Docker container across different environments in production. So this is the production deployment, just to give a high level flow, how we started with the traditional deployment with the physical hardware, and then we moved to a virtualized hardware. VMware was pioneer in this one, and then we moved to a container deployments. Now we move to a Kubernetes deployment. It's all about Dockers now. Nothing to talk about infrastructure. So let's talk about Linux containers, right? So there is no Linux container primitive in the Linux kernel. As I told, containers are part of it was originated just because of Linux kernel has the Cgroups and namespaces. Cgroups and namespaces are not part of containers at all. It's a Linux kernel feature. A container is a group of processes associated with a common namespaces, Cgroups, and those are two things which we are going to talk about these things in the upcoming slides. So why Docker was successful? Why containers were successful? Because it is having a good image management facility like Docker Hub. It has built with AUFS, auxiliary file system, advanced file system, in union file system, and it has a good resource isolation, which is achieved by Cgroups and namespaces, file system isolation, again namespaces, network isolation, namespaces, change management. You can commit, you can do your Docker image, you can change your Docker file. So you can dynamically change these things. You can actually use your Docker file to change your contents in your actually building your image itself, right? And you can share your images across to the community. And isolated process management, service discovery, better resource utilization. That's the most important factor of container is how can I effectively or efficiently utilize my resources on a particular hardware. I don't need to buy a new hardware, new host for any particular application, so that only that application can use the resources. If it is not using those resources, it's idle and it's a waste of my money and my hardware resources. So how do I ensure that no two processes intermingle with each other? No one process cannot take out more CPU, more memory, and crash the other system or crash the entire operating system. And this is what at the high level we are going to talk about today is on the namespaces and about the Cgroups itself. It's all about all the processes inside the kernel, inside the container should be sharing the same kernel. That's the benefit of the Docker container itself. Every container will come with its own minute, tiny Linux operating system. And that tiny Linux operating system is done by this namespaces, the Linux kernel feature. Just because of this Linux kernel feature, we have this PID namespace, we have this user namespace, how to manage your users, how to manage your process, how to manage your mount space, how to manage your networking, how to manage your inter-process communication within the container. Just because container has all these facilities, your application can run very well in this inside the container. Because just because of this namespace existed, you can run your application inside your container. So your container is built with these two things. So at a high level, two things, Cgroups, UnionFS, and namespaces. Cgroups is all about limiting the hardware resources. Here we are going to talk about 4 hardware resources, but only 2 are very important. One is CPU and memory. These are the common problems which we see in production. Either your application is taking too much amount of CPU, or your application is taking too much amount of memory, right? You need to control. You don't have any precaution beforehand that how much your memory or how much CPU your application can take in production. That's not the real problem. The real problem is when you cross beyond certain limits, you may crash your system. Not only you're crashing your application, you will cause outages. That's the real problem, right? Outages is not a fun factor. So Cgroups helps in how to avoid those outages. It's all about controlling and limiting CPU and memory to your container. If you limit those things to your application cannot exceed that one, because when you exceed your memory and CPU limits, you're going to be killed by your kernel. Linux kernel itself. You'll not get that more memory. I'll show you with small examples on that one. And how images, it is layers, right? It's all about layers. I'll talk about those layers in a couple of slides at the last actually. It's called as union file system. It's all about union about multiple file system directories makes your container alive. And when you see your Docker file, every statement is a layer and everybody sits on top of each other. And why this is very useful here is it will allow you to share the common layers across different containers. That's the benefit of this one. If the union file system is not there, you will be end of 1 hour to start a container, because you have to load the entire 1 gigabyte file of image and create a container on that one. So that's the reason union file system exists, because you can share multiple layers across different environments. We'll see in a couple of examples. So this is what, when somebody looks at Docker, this is what a low-level things people need to understand. It is made up with the storage, namespaces, Cgroups, security, networking. That's all low-level things. All are Linux kernel-related things. Docker is at the top. If these kernel-related things are not there, especially namespace and Cgroups and AUFS, Linux Docker will never be existing in the first place. Just because of these 3 important components exist, Docker exists for that one. So Docker, whenever you run Docker commands, think that one behind the scenes it are using these kernel features. That's the important factor here. Docker didn't invent anything. Docker is just using these features. There are other things, LXC containers, there is OpenVZ containers, parallels. Those are other container technologies, but they are all using these kernel related features. That's what I always insist. These are kernel related stuff rather than a Docker related stuff. So what is it from a kernel Cgroups perspective? It's a kernel features that allows you to allocate resources among groups or tasks running on a system. It provides a way of hierarchically group, label, process, and apply resource limits to them. In a one nutshell, you need to think about, if I create a container, I need to pin down CPU and memory to that particular container. That's all you need to remember out of the Cgroups. Cgroups is control groups, and it is contributed by Google. And resource allocation, you can allocate CPU time, how much CPU you can access, how many milliseconds you can access, and you can allocate the memory, how much memory you can access before even starting the container. You can set those online, you can set through the command line parameters. And all about networking, block devices are not so matured enough. Nobody tries those things. People try for experimentation, but for our use cases, 2 successful things are CPU and memory. These are the common things which you always use in Cgroups. So memory, CPU, block IO, I represented in a different slides, the same concepts to understand how we are talking in terms of technical. So it's all about resource metering and limiting. What are the resources I'm talking about? Memory and CPU. Any application needs these 4 things: memory, CPU, hard disk, and networking. These are the 4 things in Linux kernel perspective or any application perspective. These are the 4 things it needs. But we need to restrict. Most of the common problems happens at the CPU and memory level. That's what we are going to solve here. So either we can assign a specific set of CPUs, or we can assign a particular core or dedicate those core CPUs to a particular process. We'll see with that, or it's simple word, bind group to specific CPU. In real world, in financial world, where there are certain processes, there are certain applications which are high priority, which cannot be context switched, which cannot be switched across the machines, which cannot be migrated to different processor. Even in a same socket, you can't move from one core to another core. So you need to bind certain number of applications to specific number of cores. And I'll show you how those things works. And those are happening for real-time application for my fintech, mostly on the calculations on the bonds, calculations on the derivatives, calculation on the real-time feeds. I want to dedicate specific set of cores on that particular machine so that it cannot be moved to other one, because I need to have the real-time information, high performance. That's how I can achieve with the Cgroups. So at a high level, this is the diagrams you need to remember. So these are the low-level things, which are RAM, CPU, net, and IO from a kernel. Kernel handles these resources, and through control group, I can dedicate for a particular container 25% RAM, 25% CPU, 25% networking, 25% IO. So you can see easily if that particular application needs 30%, you cannot get it. You get crashed. It's as simple as that. You get killed. So you need to go back and change your CPU and memory limits in the Docker itself. So that's the way you can control. Now you can see I can run 4 different containers with 25%, 25%, 25%. Nobody exceeds their limits. That's how I can control through Cgroups. One diagram. So this is what in a real world resources, you can see number of cores. It's a 8-core CPU. And RAM, it can be 8 gig, 6 gig, 16 gig, or 64 gig. So I have seen 128 gig RAM. So in that one, you dedicate your applications specific to Cgroups. Means I want to use core number 6 and 7 dedicated to my web servers, like HTTPD servers. I want to dedicate to my database servers, which should be always up and running. I'll be dedicating 1, 2, 3, 4, 1, 2, 3, 5 cores on a single CPU. It's a single socket. You have multi-core machines, and I can dedicate those specific cores to that particular MySQL DB, in the sense that 1, 2, 3, 4, 1, 2, 3, 5, no application, no process can run in that particular course, in that particular socket. So it's like with control groups, I can control those things. We'll see in a lab how do we control those things. Same diagram in a different level. In the sense here, what I'm doing is I want to ensure weighted average. I want to ensure that can I have 30% of the CPU instead of saying 200 milliseconds, 300 milliseconds. Instead of saying that I can say, can you ensure that of the whole capacity as a weighted average, can you give me 30%? Can you give me 40%? So it can be extrapolated to your 16 gig, 64 gig, 128 gig based on how much memory you have, how much cores on a particular socket you have. So you can have attached weightage also to that one. So now we'll see the 3 use cases. Once you understand how this diagram works in terms of dedicating CPUs and cores in CPU and memory, you can easily handle your containers, and that's how containers make into a very successful project in the sense. Let's go into the lab. So these are 3 exercises. I will run it for you.
Sorry, Narendra.
Yes.
Before you move forward with the workshop, we have a question.
Yeah, sure. Perfectly. Please. I want to see what's the question.
Yeah, it's in the Q&A.
One second, I'll read it.
To check, but I can read for you.
Yeah, please. Yeah, you can read it for me, please. Yeah.
Okay, and says, hi. Is there any significant difference between using Docker container atop Linux machine and Windows Mac OS machine and Windows Mac OS Linux with VM virtual machine?
Yes, I agree. Okay, I got it. Okay, so definitely I always advise people, Docker containers are built with Linux Cgroups and kernel spaces. And when you talk about Mac, when you talk about Windows, you're actually talking a simulation layer. You're talking about some workarounds, and that is developed by Microsoft and that is developed by Mac. And always think in this way, real production runs on Linux. Containers runs on Linux, Google runs on Linux, Facebook runs on Linux, Netflix runs on Linux. So you will be at mercy of Microsoft on Mac. I don't think anybody deploys in production in Mac, right? It's only deployment in Linux. And why a deployment on Linux itself? Docker containers are well suitable for Linux. That's a high priority. Always think, is my production in Windows? Is my production Mac? I don't deploy in Mac. I didn't say any in my life. I never deployed in Mac. BSD, yes, those are different things. Mac OS and all those things, but always prefer Linux, and it is built with Linux kernel features. When you depend on Windows, you have to depend on Windows specific things. Yeah, they say Windows has come with this layer of handling Docker containers and all. Those are for development purposes. If you have to depend on Microsoft related, I don't run any of my applications on Windows because most of my time, my applications runs on Linux actually. And I'm very much particular about applications which are running on Linux will be running on Linux. I didn't develop any applications on Windows. So you need to depend on Docker daemon developed for Windows, and those will be Docker specific for Windows and Mac. You're depending on them. If anything breaks on, you need to talk to them. Microsoft Windows and what do you call Mac. Those are only for development and fun purposes. When you talk about production, Kubernetes and all, those are all Linux most of the time. So that's what you need to think. Windows is not production, Mac is not production. Whatever we do, we go to production. That's our goal, right? So that's the whole motivation. That's the whole crux of our learning experience. Is all about Linux. It's all about Docker containers. You get live experience. Nowadays, all the applications except .NET, all the applications can very well run on Linux. Linux is a first-class citizen nowadays. Without Linux, without containers, without Kubernetes and all, without Linux, nothing will exist. As simple as that. So let me run you through a quick example. Let me share one more time my screen because I have my cloud using environment. I need to reshare my screen again. Okay. So yeah, this is what the 3 labs we are going to do now. So immediately. So as I told, control group is all about restricting your CPU and restricting your memory to an application. Why? Because it cannot exceed its limits in production because of production outages happens because of one application consuming somebody's resources. And just because it consumes somebody's resources and you're slowing down the system, performance gets affected and it leads to outages. And outages is the single factor why these kind of technologies are keep on evolving. It's not about something fancy thing to try these things. It's all about what kind of problem I'm solving. The problem is just because my applications are taking away more CPU, more memory, I'm losing my, just because of crashing, my application have a production outage kind of things. So there are 3 things we are caring about. This is the Cgroups things. One is CPU shares, one is CPU, set CPUs, memory reservation, kernel memory, block IO, and device IO. But we'll be focusing only 2 very, very important things are the memory and the CPU link. How do I ensure that one max out 2 CPUs? How do I put a CPU affinity? Only you should be running on this particular core. And how do I have a weighted average, 20%, 30%, 40% of available resources instead of specifying only this much memory, this much CPU should be using. So 3 different options. We are going to try this one. Right. So I'm using Docker here. So the basic 2 things here is you need to have a Docker installed and max out CPUs. You need to have a HTOP. HTOP is just like a process manager, task manager in the Windows environment. You need to get installed that one. I've installed all those things. You can look at this GitHub URL. It has a clear steps to follow. And it's all Linux based because these tools are all only Linux. It doesn't work on Windows environment. So you need to git clone this project, git clone, https github.com, Docker labs, git. And after that one, you see 2 files, docker compose.yaml file, Docker file. And we will build a container through a Docker file. Docker file is the file which has only 3 instructions, nothing fancy here. It has a base image, Ubuntu, and it has 2 commands which just install an application called as a stress. And stress is nothing but just think like it's a C++ application, irrespective what application it is. All its job is to take away the entire CPU, take away the entire memory. Because it's a performance tool, it's a benchmarking tool, it's a best way to explain about how things works. In real time, you will have your applications actually using that one. So let's actually go and build that particular application. So how do you build a container? Starting with the Docker file. As I told, Docker has only 3 instructions, my Docker file. Just install apt-get install stress, and I run stress -c2 command. When the container starts up, that's where it runs. So I'm going to run this command now, docker build -t in my cloud environment, right? So let me copy the command for the easy, fast, sorry. Yeah, so let me just do, so I'm just building that one, nothing fancy here. All I'm doing is docker command to build a application called as a stressor in my local environment so that I can test it out how Cgroups works. So I'm building it. Now below I have 2 terminals. It has built successfully, perfectly fine. I have 2 terminals, one above, one below, and above one I'm going to run the stressor, and the below one I'm going to run the htop command. And I'll cut, copy, paste just to make it faster, right? So all I'm running is now I built my image. Now I'm going to run that image, that image instance of that particular image, which is called as a container stressor I'm going to run that containers. Now, before even running that one, I'll run a htop command. Htop command is nothing but what are the processes running on your operating system. That's the htop command. It's just like your task manager when you look at. But for me, this is more than the task manager in the sense that one, I can look at a lot of information. Like you can see here, my cloud environment has a 16 core CPU. That 1, 2, 3, 4, 5, 6 is nothing but 16 core of CPU. And I have a memory of 61 gig. It gives a colorful view of your task manager. What are the processes running on your host system? All I'm doing is Docker run same stressor, and I'm running with the Docker container. Now you see in the CPUs. Now you can see second one. Now it is a ninth core. It is not a CPU. It's a ninth core. At any point of time, only 2 cores will be 100% utilized. See, I said to my host using Cgroups saying that one at any point the stressor minus C2. Please ensure that my application can use only 2 CPUs at any point of 2 cores, virtual CPU. I mean to say virtual CPU / cores at any point of time. You always see the 2 cores will be always dedicated to that particular process itself. It can jump across, but if it occupies that particular core, nobody can't occupy that one. That clearly shows now 2 and 9. Those are the 2 cores which will be always dedicated to this application. And no other application can use the 2 and 9 cores. That's where we solve the problem of handling 2 cores at any point of time. Now, the second example is, can I dedicate? That's the first use case. How about that's very painful. It need not be jumping in finance and real-time applications. I don't want my process to jumping across the 64 cores. Now 1, next 2, next 3, I'm dedicated it, but I don't want to jump also. So this is the diagram. It shows that one at any point of time, you can dedicate 2 cores, any 2 cores. That's perfectly fine. Now, the second example, this I want to just stop that container. I'll stop that container so that I can show you the next example of making sure that one at any point of time, I can dedicate only, sorry, it didn't copy it, sorry. I'm just copying it. I'm just stopping the container, that's it, nothing more than that. Just to create the other example. Yes, sudo. Now you can see that CPU has been taken away from the host system itself. Now you can even, as soon as it stops the container, means that now you have freed those 2 CPUs. Now you see anywhere, all the 16 cores, you will never have any 2 cores occupied for 100% because I reclaimed that one. Now the next example shows that one, I want to dedicate only 1 or 2 cores. I don't want to have affinity. I don't want to have random cores actually. So how do you do that one? You do with the CPU affinity and the same command, but what are you doing? You're adding a new command line saying that one CPU set CPU 0 because anything it's like a C array kind of thing. So CPU starts with a 0. Let's see. Now you see none of the containers are running. Now I'm gonna dedicate one particular CPU. Now you see 0. It clearly shows that one 0 means in the CPU world, in a Linux world, it starts with 1, 2, 3, 4, 5, 6. If I say 1 means it's actually 2. So anything starts with 0 means it's 1. So that's one way. You can easily see that one I'm dedicated that particular core to that particular application itself. Again, I'm stopping it so that 1 and 0 can be confusing to you. I'll go for 3. So it will be actually 2. So let me stop again. Let me start again. So that's where you get the idea of that one by changing CPU sets here. By just changing CPU set 1 or 2, you can change which particular core you're running your application. One last example of this one is, how about weighted averages? Now I want to kill that process. Now I kill that container. Now I want to have dedicated 20%, 30%. I don't want to have this. That's a diagram. Clearly shows I dedicated 1 core. Now I want to have share constraints. So there is one more Docker option called as a CPU shares, 760%. I'll be running 2 containers, one with 75%, one with 25%, instead of dedicating those cores. Sorry. CPU stress, Docker run, command not found. Sorry. just the cut, copy, paste. So what I'm doing here is I'm running two containers, and one will be occupying 75%, another will be occupying 25%. So running second one. Now, how do you check that one on the terminal? Is through Docker PS and Docker stats. Now you can see one is occupying 100%, first container, and the second container will be 25%. Now, how do we check? Docker stats. You can see easy here under the CPU, 74 and 25%. At the same thing, you can specify even the memory, 1 gig, 2 gig, 200 megabytes, and all those things with same parameters in a memory related arguments. So now you can easily see on the above screen, I have dedicated 75% to container 1 and 25% to container 2. So as a good citizens, we need to stop these containers. I can stop with this one. There is a script which always stops this one. Just have to move on that one. So that's your, what do you call, that's your C groups at a high level. The same thing you can allocate main memory also, in the sense I want to allocate for this process 200 MB, 300 MB, 500 MB, 700 MB, and all those things. Now you can see I reclaimed my CPU and it's all in a normal state. That's the example which I want to show in terms of Docker, C groups, and all labs are there. You can try it out, all those things. And one more thing I want to show in terms of namespaces, because we are running out of time. I want to talk about much more on the namespaces. And after that, I can take much more. If anybody has any question, no questions here. I want to stop sharing. Again, I want to share my slides now. Anybody has any questions?
No question, Narendra.
Yeah. Okay. So now this is what internally it will look into C groups, right? So we talked about max out 2 CPUs, set CPU affinity, and CPU share constraints. All the labs are there. And this is what happens inside. These are all kernel related things. If you're looking at kernel, this is where if I want to dedicate CPU set 2 CPUs, 3 CPUs, vCPUs for a particular database or a web server, or Apache web server, or any kind of Nginx web server, I want to dedicate CPUs and memory on a command line. This is what you do at the kernel level. This is not a Docker related. This is kernel. Docker will do it for you behind the scenes, but end of the day, Docker will be using these commands in that one. So namespaces, this is important thing. It's all about how do I ensure that one process in one container cannot see what is happening in the other world. As I told, there are multiple processes running in your operating system, and no one process can interfere with other applications configuration, other applications processes itself, right? So it's all about how do I control my access control. So now when you look at Linux containers, this is what you need to look at. Where does namespaces fit? Where does C groups fit? So C groups is always part of the kernel. Namespaces are kernel driven things, but tied up to a container. I'll show you how those things work in a real world. As I told, C groups limits how much you can use. Namespaces limits who you can see, who you can talk, right? Multiple namespaces. Just think that one. These are the 6 namespaces, which is nothing but to make your container alive. These are operating system. As I told, container comes with the Linux operating system, tiny Linux operating system, plus your application, plus your dependencies. So what does Linux operating system or a tiny Linux operating system consist of is PID namespace. It has its own process, managing process. It has its own networking stack. It has its own mount stack. It has its own Unix time sharing thing, and it has its own IPC. As I told, it's application plus dependencies plus your operating system. Because any end of the day, your application should be running on an operating system. Now in the container, I'm packaging operating system plus your application plus your dependencies. That operating system is nothing but that from what you see, that is nothing but a base image. That's what it is. So namespace API, the low level things, how does it create? Through clone API, through the clone system call. Unshare, that is how you create a new space for the current process. It's a fork plus exec plus wait. That is a Linux system call or a Unix system call where you create a new process. And everything you can find in a directory called as proc PID namespace. PID is nothing but a process ID. Every process which is running, which should be specific to tied up to ID, and you can know how many mounts are there by running this wc-l command. So as I told, it is nothing but a tiny operating system, we are talking about namespace is nothing but you get your own isolated operating system. You run in your own den. That is what container is all about. And every process what you run, it has no PID. It has its own process ID, starts with 0 and starts with 1, which is parent ID, and it is different from the host. If I have 10 containers, I have 10 PIDs with starting with 1, because those are all tied up to that particular container. Because when you look at the host, the PID of the host is 1, where you're running your container. That is not the same thing what you see inside the container. Inside the container is your home. It's like an apartment. It's your stuff. And when you look at the whole building itself, that's called as the entire host itself. Host is a building and the container is your apartment. That's how you need to think about it. And when PID 1 goes away, obviously the whole namespace gets killed. I'll show you a small example. How do you understand that one? So this is where the system calls, right? It's all about what kind of system calls are used. It's a set namespace and unshare, which is used for creating a new containers. When you run a Docker run means under the hood, it is calling this namespace calls apart from the Cgroups APIs to make sure that your container is alive with its own operating system. It forms a hierarchy. This is pretty straightforward. And now I will show you a small example of again. So how do I ensure that my container is actually seeing the host one or not the host one, independent of this one? Namespace behavior, same thing. I'll show one example on this one. Networking stack. As I told, every container will get their own networking interface. We call it as a loopback interface. You have your ETH interface. We call it as a virtual ETH interface. It's the way you connect to your container. How do containers talk to each other? How do container talk to a host? It connects to the Docker bridge. And there is a vETH pairs. And everybody gets its own networking stack. Think that it's like a small, minute VM. I should not use the VM. It's a minute Linux operating system with dedicated CPU memory and dedicated operating system. It has its own routing tables. These are all networking stuff. It has its IP table rules. Docker takes care of it. You don't need to do any of these things. Docker very well, effectively has implemented these things default on behalf of you. It will be mostly useful for the ops guys to understand what happens behind the scenes. And when something goes on the networking side, you need to ensure that how do you troubleshoot that one? So Docker Zero Bridge is the guy who connects all the containers, should be talking to the Docker Bridge. Docker Bridge is the entry point for your networking interface to the host. That's what you need to high level, you need to understand. With a small example, I'll show you now. Again, I need to share my screen again. Sorry, that's a cloud environment. So I have to switch back again. And I'm sharing again my cloud environment. Hope you can see my screen. Are you able to see my terminal now?
Yes.
Guys?
Yes.
Okay, cool. Just I want to show the examples in a very simple way how to understand namespaces, right? So as I told, I want to run a simple command. Let me run the same command which I run it, right? So Docker run -it. Alpine is a base image. Don't worry what it is. It's just an application. Think in this way, right? IP address show. And all I'm doing is show me my IP address of my container. Sorry, typo. Sorry. Show me my IP address of my container. As I told, every container comes with its own IP address. It acts like an individual operating system or individual host. Now, all I'm doing here is, see, that is what does it say? It has its own, comes with its own loopback interface. It comes with its own Ethernet interface. And this is what it connects to. You can see 172.17.0.2. That is the IP address of this container. Now, I want to see what is the IP address of my container. If config, right? This is my host, not my container. See how many things are there in my host, right? So if I look at this one, just to get a high level view, what is my IP address? There are multiple networking. I have implemented this one, but generally I'll be looking at my IP address will be mostly my wireless provider 192.168.122.1 because I use a lot of projects here. So that's the reason you see multiple interfaces. Docker interface is also there, part of this one. Now I see two different things. One, without a host interface because it's a container itself. Now I want to show if I put net equal to host, I'm saying that one, I want to directly see what is happening at the host level. See, clearly shows that one, I'm actually looking at what is the host related configuration. In production, you should never ever try these things. Always advise, strictly disclaimer, don't try anything in production like this. Never have net equal to host. Means that you're actually seeing the host related configuration. As I told, container is a self-isolated. You should see only your stack, your process. You should never ever see your host related stuff. So that's what I'm differentiating that one, saying that one, what are these things? This is called as isolation of your networking stack. Now you see, you have just isolated your container and you have your own IP address. And that's called as, what do you call? The network namespace. It has its own networking namespace. Let's try one more example. Process, right? Process. I want to see what is the process running in my container, right? So it is not running anything. So that's fine because I didn't run anything. So it's a PSEAX starts. So I can run with this one. That's all the process running in my container. Now I want to see what are the processes are running in my host. Now you see, clearly shows that one. Let me cancel the below one so that you can see very easily. Right? So all I did was pass the host. I want to know from a container point of view what is happening at the host level. Again, don't do this one in production. Production is not advisable. Just to showcase that one, how this namespace works. That's all it says. See, without host, if PID equal to host is not there, means that I don't want to see what is happening in the host. Default behavior is this one. Just show what is happening in my container. That's it. Nothing more than that one. If I look at my namespace, ls, let me do the ls thing. Now you see ls minus l. This is my individual Linux related operating system inside my container. That's what you need to look at. My container will get its own directories like a bin, dev, etc, mount, opt. This is called as a namespaces. It has its own dedicated operating system. That's all it matters. Namespace is nothing fancy. All it namespace is having a mount space, user ID, passwords, mounts, and network namespace, and IPCs. That's the only two examples which I want to show. What is this namespaces? Just because you get its own namespaces. When do you need host means while during debugging stuff. When you want to debugging how container is talking to your host, how the port forwarding works from your host to your container, that is where you need those host related for debugging, not for your deployment into production. Now again, I switch my slides, stop sharing again. I want to again switch my slides. Share the screen window. And that's the thing which I just showed you. How do I ensure that networking namespace, mount namespace, and process ID are everything related to process related tied up to particular container. Every process have its own root and it has its own roots file system. It can, your application can very well use those things inside your container. You can't use the host related things. You can try it out with the host command, but it's only for debugging and testing purposes. And that's what it explains all about. It has its own mount points. Same thing what I just showed you in the example. And always IPC. So all people will ask what is an IPC, why it is an IPC. IPC is just an inter-processor communication. How do one process can talk to each other in the same container, not the other containers. It should be container should be talking to container, not a process in a container should be talking to a process in a container, because every container will come with its own IP address, and IP address talks to the other container with other containers IP address to the Docker bridge, using the v0 networking, which is implemented by Docker. That's the only thing. So just at a high level, at the kernel level, what it says is UID. This is user ID, and a group ID is a GUID kind of things. So how does each container, as I told, container is just a process in a Linux world. It's just a process running just like any other process. Kernel doesn't differentiate. Is it a kernel? Is it a Docker container? Or is it a regular process? A Chrome browser is running in my host. It doesn't differentiate. Everything decides by just with a process ID. And it doesn't differentiate anything. But with a UID, if it is 0 to 199, that is how container get maps to the Linux host PIDs, UIDs, I mean to say. And 0 to 199 for container C2 is mapped to UID from 12,000 to 1399 on the host. It's just a numbers. When you try to debug anything, you need to look up whether these PIDs are actually mapped to the right host PIDs, just to understand what kind of UIDs have been actually mapped to a particular containers. That's just to want to ensure that. And UID, as I told, you can have your own user IDs inside the container. You can set your user IDs through Docker file. You can set MySQL D is a user ID, or MySQL is a user ID to run this MySQL server. You can set those user IDs inside your container. That user is totally isolated from one container to another container, and that container's user IDs are different from the host related stuff. Just to make sure that one, hosts are different and your containers are different. Whatever you can do operations on the host, you can do on the containers with restricted privileges and all. You can get your host name, you can get your system name, you can get your what is the operating system version release inside the container, outside the container. Inside the container, you will get the container related information. Outside the container, you'll be getting the host related information. And that's how namespace makes that container as a real working project, real working container. So simple namespaces are created with a simple clone system call. No black magic, no nothing, anything Docker is doing fancy. It is just calling the system call from the Linux kernel, clone system call. And with that one, you actually create a new namespace. Just to get a highlight, when all the namespaces are available in /proc with that process ID and with the namespace. You can look at your Cgroups, you can look at your CPU set, you can look at your memory related things. That's what it says. And this is the one last thing which I want to share here is copy on write, important one. What do you mean by copy on write here, right? So copy on write is nothing but, sorry, excuse me, my voice is broken. Okay, so copy and write has two different things. One is on a RAM, one is on a hard disk. What does copy on a write is means that one, whenever Linux, in Linux world, in Unix world, whenever a new process gets created, it's all about three system calls, fork plus exec plus wait. What does fork does is it creates a child process. Every process, every application you run in Linux, we call it as a process. When how the operating system sees through the process IDs, right? So that process is actually doing the work. The parent is a guy who will be actually allocating the work to the child process. We call it as an init. Init is the first process. It's like a first process in the Linux kernel. After that, rest of the all processes are child processes. Doesn't matter MySQL, Apache server, any of your application browser, any application you run in Linux runs through the process IDs. So parent is a guy who actually controls all the process. If you kill the parent, and only root will have that access. And if you kill the parent, you kill the entire child process, entire application itself. So fork is the only way you can create a child process, and you actually, any command you run, it's actually creating a fork plus exec plus wait. Wait means wait is actually the parent is waiting for the completion of your child process. So what are the commands I run? It's actually created a child process. It does its job. Docker run command, stressor command, whatever commands I type it on a Linux terminal. Then after it completes, it returns back to the terminal. And that is what it is. It's all about copy on write. Why copy on write here is when you're not, when it's actually you're copying all the parent related data structures, parent related files, parent related message queues, parent related, all the metadata information related to parent, you actually pass on to the child. If both are equal, if both are same, it will not create a new copy. Think like if I want to create 1 million processes, that will consume a lot of resources. So only the process which actually gets changed when you are actually changing your child process to run something else, that's the only time where it actually creates a process. Rather than duplicating, it will actually create a new process only when something gets changed. That's all it is, just a high level things. And it is implemented with fork and mmap, memory map things. Those are two system calls you should always remember when we have a copy on write or a copy on a write on a file system. Now we'll talk about a file system. As I told, without copy on a write, without Cgroups, without namespaces, containers would have never existed. If copy on write is not there, yeah, Cgroups taken care of, memory and CPU, namespaces taking care of all the isolation, container isolation in terms of operating system related features inside the container and outside the container, so that it doesn't see what happens at the outside level. You're self-contained, you can be handling your own internal stuff. And last one is the copy on write. If you can't see copy on write working properly or this union file system existence, think that one, if I have 100 containers each occupying 1 gig, think about 100 gig is gone. And I don't think so memory is so much, main memory is not so much cheap enough, or in a technological term, you can't use so much amount of memory. You can't run in the first place. And in order to start also, it will take a lot of time because 1 GB of application needs to be loaded every time. So that is where copy on write helps here is, it will just ensure that only the right portions of an image layer, we'll talk about in next slides, only the right portion is only the change one. Rest of the things are shared across all the containers. I'll show you with an example what it is. Actually, it is implemented, as I told, create a new container instantly. How it can create very fast through this AUFS, overlay FS, because of these file system related stuff, it can create very well a new container very fast. That's the beauty of the containers, is faster boot times. That is what it sells. Docker is all built with faster boot times. That boot time is tied up to this just because of AUFS, overlay FS, and different technologies are there. ButterFS is there, ZFS is there. They are implementing at the file system level. But Docker supports all those storage drivers. If you have any of those things, you can very well implement that one. That's the beauty of the Docker. Instead of copying the whole file system, it will just copy what is needed, or it will create a new one only when there is a change in the parent one, when you have some write related stuff. I'll show you the diagram itself. Now, this is what an image will consist of. So image, you need to directly map to your Docker file. If you look at your Docker file, that's every layer, every command you write in a Docker file is actually a layer in image. So you should be very cautious about when you do an optimization of your images in your Docker, you need to ensure that your base image is perfect. First thing, less size is always helpful. Then you can see in the diagram is a very lot of information in the small diagram. See, clearly says I have a kernel, Linux kernel with the namespaces, and I have a base image. It can be Debian, and I have add my application. Emacs is an editor in a Linux world, and I've added an Apache. It's again an image. And at the top level, my application, which is actually changing the code. My code has to run. That is my personal code. Apache and Emacs, any kind of application, software related stuff, which is already available or used by other containers also. So Docker is smart enough to use the same Apache image layer across different containers. So how does it do it? Through the AUFS. That is called as union of the file systems. It's like a union of multiple layers. And it will always maintain the read-only copy, which is not getting changed. Only the change, the writable thing is your container. Your container gets your changing. Your dependencies, your packages, it will change in terms of versions, but not in terms of you are not changing your dependencies. You're changing the names of your dependencies or versions of dependencies. That time it will rebuild those versions. Other than that one, your application, your code, which is getting changed. And that's the place where Docker will say that this is the only place where I'm going to write it. I'm not going to load everything. I will be loading only the read-write layer, which is on the top layer. That's the only layer which I loaded. That's where it helps Docker to load it very faster. Now, this is what one representation. When you look at your Docker file, when you look at the base image node, you need to read it from the bottom up rather than from a top to bottom. Bottom up is the first base image. It's a node base image. I'm creating a directory there. I'm making sure that is my working directory. I'm copy my package.json from my host to my Docker container, running npm install so that it can install all my packages, and I copy my user source app. This is where your application sits there. Your application, where you coded your application, then you are exposing a port 8080 command npm start. You ran some front end application, and that is where your read write will come place. On the top layer is the only place where your application is there. Rest of the things are all your read only layer. That's what it shows. See, this is simplest example. This is what I was talking about. When you have two applications which uses base image, everybody uses the same base image from Ubuntu. Entire organization uses the same image. So Docker will not always download that base image every time. It will download one time. It will only use only one time. It's like a shared library when you're talking C++ world. And you have Java JDK dependencies always across all 10 applications which are using Java, same JDK. I'm not going to change until it is the Docker file has been changed. And everybody is using Elasticsearch. But what is the changing thing here? I have an app 1, I have an app 2, I have a container 1, I have a container 2, I have a container 3. All three will be using this common 3 layers application binary, Java, JDK, Ubuntu. This will be common across everybody. That's how Docker will run fast or load fast, spawn the container, stop the container only by looking at the top layer, not the entire layer. Layer is already there for you. It will only update, it will only change the above layer, it will only start that one. That's how you need to remember. That's called as copy, what do you call cow? We call it as a cow, copy on write storage. So now you look at different overlays. The diagram itself says that one, I have a lower directory, I have an upper directory, I have overlay file system. It's like a AU file system, better version of union file system. So I union these things to make, it's a union of multiple directories in Linux world to make sure that one, your container can reuse the read-only base image layers. That's all it says about this one. It's all about unioning about your layers in that one. So there is one tool which I can show you, a tool to understand how do I optimize my base image or my Docker file or my image. Let me use the word image in a generic word. Image is 500 MB, 200 MB, 800 MB. I don't know. How do I optimize base image? There is a very good tool which is called as a dive tool. I use always actually in my environments to ensure that one, how my images are built, how do I optimize my image, how do I fast build my image when I implement my CI/CD. Every time it has to rebuild my images, right? So that time it takes a lot of time for developer productivity, gets impacted due to large loading time, large building time. So with the dive, I can understand individual layers. I can look at where I can change the layers, where I can optimize my layers using this tool so that my bay or image size will be reduced. Two things, one is base image, which is actually from there you actually build it, and your actual image of your application itself. Where can I reduce my application's image? By reducing dependencies, by looking at the right dependencies which I care about. I don't want to put a lot of stuff there. And I'll show you a small example. This will be a last example. And I'll share one more time. So this is the, how do you install it? It's all in the GitHub. This is the dive, which is given by Wa Goodman. So that is the guy who developed this tool. And you run the dive tool to understand what happens inside the container. So last example to show today, this one. Again, I'm sharing my screen with my cloud environment. Let me share my screen. Window, cloud environment. Yeah. So let me go to my cloud environment. Okay. So this is my application. So I have downloaded one application, Node Starter. It's already there in the slides. So all I'm doing here is I have this Node application. Nothing fancy here. I have two Docker files. One Docker file just to start with. Okay, this looks like a production. So 1 second. So I start with the Docker file which is not optimized. So I'm just copying that one. Original file just for my training demo purposes. I just copy two files. Yeah. So now this is my Docker file, which is not optimized. So let's not worry about how it is optimized or not. It just look at this instruction. Just 1 second. Just it's a Docker file. I'm just checking out 1605, 1605. That's perfectly fine. There are two Docker files. One is original, one is optimized. I want to run this original one. When I write this Docker file, it is inefficient. How my dive helps me to 1 second. So Node Starter. I'll show you that when it runs, you can easily understand. So all it does is I'm running a dive. I'm running a Docker file, which is in the current directory. I'm building an application, Node Starter here, right? So it should not be IT. It should be just IT. It should be there. So I'm building an image called as a Node Starter. Now let's see, it is building an image. So what it does, it is getting the Node.js components. It is getting all the dependencies. It starts installing those dependencies inside the container. And every line in the Docker file is a layer itself. And I'll show you explanation about this one in our nice blog. Right, this is what it is. You can read it afterwards also if the screen is a little bit smaller. I know we are exceeding the time. As I told, it helps you out to how do I reduce my build time, how do I reduce my run time also. If I reduce my build time, it helps developer to push the code very faster because it has to build Docker image through Docker file, then you have to push to the Docker hub, then you need to pull that one, then you need to run the container. So there are multiple stages in your pipeline, in the CI/CD pipelines when you use Docker in your production, right? This tool will help me out to optimize my Docker image. So that's the project which I cloned it, and I'm running my Docker. So I'll show you with the example itself. Let me see whether it's completed or not. Just want to say that one. So it's running still. Now you can imagine this one. I'm building a Node.js application itself. See how much time it is taking. Think about a developer is adding 5 lines of code. Then again, he builds it, tests, build, test, build, test. How much time he's going to waste in terms of building. So where the optimization of Docker images helps here is he can make sure that your images are built very fast. See, just by running dive itself, it's taking so much of time. It's like actually looking at what happens inside my container in terms of layers. It's like opening up a body and seeing the body parts. It's like a Docker. It's like a doctor looking at an operation, doing an operation, a heart surgery or something. So dive does the same thing. It looks at the internals of the Docker itself. See how much time it takes. Even if I ran many times, even the caching is there, still it takes time. It's for a small Node.js application itself. Now, let's look at that. Let's give it 1 minute because it takes time to load that one. See, wait. So it's all the information, what are the packages it has installed. I want to just show you the Docker file. That will be easy for you to understand. Let me go here. I want to just show the Docker file for you so that I don't want to show on the terminal. This is my sample application. Now this is what my Docker file looks like, right? So it has apt-get install, all the package dependent. It has installing wget, curl, it is installing node source, it is installing node versions, it is installing yarn versions, it is copying the files. Then again, it is installing all the node modules related to some AWS related packages, AWS SDK and all those things. Then it is installing run image. Sorry, it is actually running some base image called as a fusion base image. What are the version he's using? And it is starting that one. Then again, running with all the node related dependencies. So it is a multi-stage build here. So he's actually removing all the intermediate files during the build. Node, when the application runs, it might be creating a lot of intermediate files. So you don't need to be those intermediate files part of the container. See, every command you run, you're actually running inside the container. So you need to avoid the temporary files. So that's the reasons. Wow, still it is running. Still it is running. Interesting. So successfully built. Yes, it has tagged now. Let's see, a couple of seconds. So that's the crux of this analyzing image. Yeah, this is where we need to start. Yeah, now you see it took at least 1 minute of this one. What is the important thing you need to observe here is you can see the layers here. This is called as the union file system layers I was talking about. These are the image layers. These are directly tied up with your, what do you call, in your Docker file. You can easily look individual layers. On the right hand side, you can look at what are the system calls being used inside those layers, right? So all the layers, you can directly dissect what is happening. This is what I use whenever I download some third-party Docker images. I go and verify that one. Is there any security loophole? Is there any something which I don't understand? Is it something which is he's doing something tricky or something? I can't trust those things. So this way I can validate these things by looking at the individual layer. See, right hand side getting changed by the system calls. Is it the system calls is a security related loopholes? This system calls can expose my host. This container is getting leaked. Container is leaking information to the host, or it is accessing some host related information. This is how I can check for the security related things. I can analyze what is my image, and I can go and look at where I can optimize. So important thing you need to observe here is my total image size is 575 MB and potential wasted space is 250. This is very awesome tool to get me upfront saying that one, you need to go and optimize your image. So you're wasted 250 MB already. So it can be used by other container. You can use your container will be much more faster when you use less memory. Less memory is the best way to run your containers efficiently. Now I'm Control C. Now what I'm doing here is I optimize my Docker file. You can look up that one Docker file because I club those things using Docker best practices. How do you create a Docker file? I club those run commands into one. I'll show you that one also, what I did. Docker. I'm just copying it to a Docker file because that's what it says. Default thing is there. I moved that one. Sorry. Okay, that's fine. Okay, so I will be running again my node starter application. Now this one with an optimizer. I need to ensure that I use less memory. That's the goal here. And how did I do my optimization? I'll run through your blog itself. And this is what you use the tool to optimize stuff. That's all we care about. Optimize. Yeah, this is what I was talking about. So let's talk about. So it has 1.5 gig for us. It's 500 MB because it's always optimized a lot of stuff. I already downloaded already. So after optimization, what did I do optimizations here? See, all I did was there are multiple run commands like this one. So you should avoid. There is a Docker best file practices. You should not have. The more you add more commands to your Docker file, think that one you're actually adding more image layers. So it has to load those many image layers. It has to unionize those image layers. That takes time. If you put all the run commands by putting an ampersand, by putting clubbing into one command, that means that you're actually loading only one layer, and that becomes much more efficient. Wherever you can use it, use the and command, and ampersand and. I mean to say club those 10 different commands and make it one line command. So this is what I was telling. You need to know the low level things of Linux things. You need to know how to club the commands. You need to know what kind of Linux commands I'm using. Is it a worthwhile? I need to use a wget. Do you need a curl command? So these are all Linux commands. For this container, for testing purposes, I'm just showing it out. And when I club those things by following the Docker best file practices and using this kernel related feature, copy and write things, it will optimize my container. See, I just ran one Docker run in the Docker file. I have only one run command by putting a delimiter called as a backward slash so that it can be a single command. I don't want to run in a multiple commands in that one. So this is what I can run through multiple commands through ampersand. So I want to run instead of 10 different run commands, I just clubbed into one command. That's all you need to remember. That's the goal here. 1 second, I'll just check again what is happening with my dive. Still it is downloading. So still it is building. Yeah, you can imagine that one, how much time it takes. And this is how you actually, you actually optimize your base images using this tool. And two different things, as I told, Docker security, I didn't talk about it, but as I told, it will take its own session. I'll talk about that one in next webinar, if that is possibility. For this particular session, I want to just close it with the Cgroups, namespaces, AUFS, how do you use a dive tool, how do you set your CP affinity, how do you namespaces works inside the container, outside the container, how do you pass with the net equal to host command, how do you look at your host related stuff in terms of process, in terms of networking. That's the whole crux of that one. And one more thing which I want to, before that completes, I want to talk about this security related stuff. As I told, I don't trust outside images. I only trust the images by looking at what is happening, third-party images. I mean to say, if I build my images, I'm fine with that one. But when I download a lot of open source related images, I will validate whether there is any security loophole or not. So Docker recently, 6 months back or a year or something, Docker has added this new utility called as a scan. So if you want to look for vulnerability issues in your images, images are the most factor. Containers are actually running. Images are like a file system or a tar file sitting there. Images are the actual things which actually used to build, you actually run a container. Containers gets instantiated with the images, right? Docker scan, hello world will show up any kind of security loopholes you have inside your container. And there is one simple command, not a fancy thing. So Docker scan, you can pass on your Docker file. And this is the utility from a Docker itself, because I trust Docker because it's their tool. And they run security related stuff on their commercial or enterprise related product, which is called as a DTR, Docker Trusted Registry. Registry is the place where you actually store your images, and you need to keep on continuously scanning your images. We do. Nightly, we scan. People will be keep on pushing a lot. Internally also, doesn't matter external. Internal also, people will be pushing a lot of stuff. So I need to run my CI/CD pipeline to run continuous integration or continuous testing or continuous vulnerability scanning on the images which are actually pushed to my internal Docker registry, so that I can know any security loopholes are there in those images. If anything is there, that will be a red light, that's a no red flag, and that will be not be allowed to push into the production until those security thing has been fixed. Now the tools is very much matured enough. Before, it was a very mandatory effort. I used to write off a lot of Python scripts and shell scripts to do those things. Now Docker is coming with this scan tool itself. Now you can use the Docker tool itself. It will show all the libraries which can be exposed to the security leaks kind of thing. So you need to keep up to date by running these tools. And this is how you run to know about your security vulnerabilities in the Docker image. That's one thing. Now let me see here. Now you see. Now you can easily see that one after I ran the dive on the optimized Docker file itself, where I clubbed my multiple run commands. I used multi-stage builds, avoided the temporary files which gets created and will be part of the image itself. I deleted those things by using the multi-stage builds. Now you can see from 575 MB, I got to 470. I saved 100 MB of my main memory. 100 MB, I can reduce the memory, means that itself is a lot of optimization, right? You can see potential wasted space 150 MB. Still there is a scope for more optimization. So that's where it says this tool will help you to optimize your base images. And that's one thing I want to complete this session. If I have time, I can continue. Alina, what do you want to do, Alina?
I don't know, we have 15 minutes left.
Oh, 15 minutes? Okay, I can continue. If people have any questions, they can ask me. I can continue. I have a couple of slides. Yeah.
Okay, continue. Q&A box is clean.
Okay, perfect. Okay, perfect. I will continue now. So I can talk about security also. At least people have an idea. So this is already there in the GitHub. So you can go and read individual steps, what I have done, how do I optimize those things, so that it can give you a perspective of what are the things I need to take care when it comes to the images. How do I optimize the images via Docker file so that my containers can run efficiently, container can run very fast in my production environment. On the same host, I can have multiple containers. Perfect. So now I'm going to share my slides again. Give me 1 second. So this, I'll be talking about security. That's the important factor. As I told, that itself is a different, that itself will take 1 hour, but I'll give you highlights of that session. So totally a different session. I can talk about end-to-end security, right? One by one to implement with the labs and all. So, okay, this is what we just completed. So you're able to see my screen, right, Elena? My slides?
Yes.
Okay, so this is what we learned. This is what you need to look at the container means, right? It has its own tiny operating system. It comes with namespaces plus Cgroups and AUFS. AUFS is not listed here because it's a part of the images itself, not part of the container itself, right? Image means it's all about the Docker image. Here, container, this is actually running in production, running instance, right? You can see it has its own IPC, it has its own network, it has its own PID, it has its own namespace, it has its own host name, and it has its own Cgroups. See, there are 2 applications. One is a file puller is an application, one is a web server is an application. And I can dedicate this Cgroups for individual application itself. Right? That's the beauty of this containers. So that is how you need to visualize. So whenever you talk about Docker, this is what an engineer, this is what a real-time and in-depth Docker internals, or you want to understand what happens behind the scenes, this is how you should be looking at, rather than just saying a container, an image, a container will run with this command, an image, you should be running these commands to build an image. You know, to look at the log files, you need to look at the statistics of your Docker containers. This is how you run the commands. But this is one step ahead of that one. What happens behind the scenes? So whenever you think about a Docker container, end of the day, no black magic here. It's all about namespace, Cgroups, and chroot. Chroot is nothing but it's a BSD jail concept previously. It was there already before. They just used with the namespaces and Cgroups. That's namespaces concept. That's it. It's like isolating your file system. The host file system is different from the container file system. And Docker client and your containers is sitting on a host AS sitting on a hardware. That's your virtual machine or anything. A Docker client will be talking to a Docker daemon. The commands it will be running is a process status, run container, get images, download images, pull images, execute commands on your container. And if it is a pull command, Docker daemon will be talking to a Docker registry. It can be a public registry or a private registry, whichever registry you use it, and it can be a cloud registry. You pull, push, search for all the images available on your Docker registry or your container registry. And internally, Docker daemon will be using lib container to talk to the host OS. That lib container will have these APIs of namespaces and Cgroups, which makes your container lively. That's one thing. So Docker security, as I told, at a high level, I will talk about these things. Pretty straightforward, not a complicated things. Just to implement that one, you need to write some, you need to use some CLI commands. Those are clearly it shows. So security capabilities and SEComp capabilities. I have some examples. I'll show you that one also. So what here, security here is, what kind of capabilities I can allow for the containers. Can my container have networking capability? Can my container can access my host things, which I told you should not do it in a production. Can my container itself, by default, your container gets root privileges. By default, you're inside the container, your root. Whatever you can do inside the container, nobody's going to question you. But it's a security loophole, right? Still, it is a root inside the container is not advisable because it's always ensure that one, you disable those capabilities. Change owner capability. Cap means it's a capability. Change owner, change group ID. This will, in certain scenarios, when you, by default, these things are there inside your container. When you disable these things, you are making your container more robust. When you enable by default it's enabled, this could cause some problems to your host. When somebody can hack your container, that happens always the time. People don't follow the security policies. They hack with the same UID, GID onto your host also. Chances are there, they can hack into your host. Means your container is leaking information to the host. What if you're mounting some host related configuration files to your container? And it can go and fiddle with that particular paths because you're actually mounting that path from your host. You don't want to copy your secrets. You don't want to copy your environment variables, which consist of secrets, into your container because anybody access to that image, he can look at your secrets. So that means that in production, I had to use my host to communicate with the container. Means that I had to pass some information from container to the host. From the host to the container. So container has access to the some directories in the host. -v option. I used to mount those volumes of configuration secrets that should be mounted from production. Because anytime anybody can look into the Docker image, but nobody can find because that information is part of the host. When you run in production, your container might be able to see, but not at the image level, not at the build time. At the runtime, your container can only see. There are multiple security related things to reach a container to see that one. What if your container is a rogue? What is the developer does the mistakes? People always do the mistakes. That time you need to ensure, you need to follow these practices. Change ownership, change group inside the container should not be allowed. It's a simple thing. Docker run, cap drop, net raw. So you're dropping the network related stuff on that container. If it's a standalone container running some bad job or anything, doesn't require any networking stuff, please drop those capabilities. And if you don't want to do SSH, people do always all the time. They run SSH inside in the container also. Strictly don't do those best practices. Don't do those things. Enable SSH in that one. You should not log into your SSH. You should disable. You should not have SSH service running in your container. You should ask the question. It's an app server. It's a Tomcat server. It's an Apache server. Why should somebody log into that SSH, into that container? There should not be any SSH. Apache server should be running like a container. That's all. It should be the goal. And that's how you can drop. You can add your capabilities also. Most of the time, it's a zero trust in the sense, drop everything, then you start adding the functionalities which you want to add. That is the way to look at the solving the security related capabilities. And one more thing, cap net raw means it's all about sockets. It's all about raw sockets. You can remember that if you know Docker command line var run docker sock, right? That is the socket. That is how Docker communicates with the Docker daemon. And Docker daemon communicates with the containers. And that socket is always available so that Docker can communicate to the Docker hub. Docker can communicate to the images or send commands to the images, run commands on the images, or run commands on the containers, running Docker commands for the containers, running Docker commands for the images. Everything has to go through this Docker socket. That is how Docker communicates with the containers or the images or the Docker registry. All are REST-based APIs. So you can't expose that one to the container. And you need to maintain your Docker security for those things also. So those are times when you need to disable for the containers, networking, or any related change ownership, change root permissions, disable root permissions, and have specific user IDs. Don't have default user IDs like a root inside your container. That's one thing. And security, this is one more thing. SecComp is all about how do I disable or enable system calls inside my containers. If you look at the dive command which I ran, actually on the right hand side, if you have seen, those are the actually system calls. And that system calls can give you some idea about what are the system calls should be allowed, what are the system calls should not be allowed. And that can be defined in a JSON file. This will help you out. These are the system calls disabled. Change ownership, change group, change permissions for a file system, read only, make it the file system read only. So those kind of system calls can be dropped or can be disabled through a JSON file. All you need to pass it on the JSON file. I'll show you with an example where that example is there. Right? See here, change mod, you should not be able to allow to permissions of a file, a directory, or a configuration file. If you are able to change the configuration file or a secret file or any related to user ID password you store in a text file, if you change the permissions, means container gets access of those root permissions for your host related files. And that's a security loophole. So you need to avoid means this application at any point of time should not have this capabilities or should not have this system calls part of that particular application to be used. That's all. You create a JSON files, put those system calls. Please ensure that the system calls should not be enabled for this application. That's what it's all about, it says. And this is the Docker thing. Just I talked about security scan. And I talk about Docker security, just to give a perspective. Again, this is the last slide I have. And these are the one thing, these are the commands which I always use for security related stuff. One is a process status. I look at what is CPU, memory, what is the stats, Docker inspect, Docker history helps me out. What are the layers has been changed? What are the things I've added? What are the things have been deleted, which helps me out to optimize the base images. I want to look at what are the networks opened. What is the build time? What is the secrets? So what are the secrets available in the Docker? So these are different Docker commands useful for your testing for your security or debugging, troubleshooting, whatever you call it as. This one slide this is the last slide I want to share. How do I enable security in my CI/CD pipelines? It can be starting from the development itself, where the developer actually commits the code. I'll be running some static analysis tools on. So generally I use Flaw Finder in C++ world, and SonarQube is one of the good tools for Java, Python, .NET, and all those applications. You need to run these tools at the development stage, not at the production stage. First, parse your source files. Ensure that one you run your, apart from your building your application, you need to run your security tools also. People run in testing environment, UAT environment, beta environment for testing, but I do on the development side. I enforce developers should follow security policies at the development stage itself, before even actually code gets committed. And when they send a pull request, I'll be running this CI pipeline. In that stage, a security pipeline will be at the initial stages. After I run on the source code, then I'll be going into the Docker stage. Now I'm building a Docker file. Now I'll be scanning that image through the dive thing. Does it have any related to security related vulnerabilities on the image layers? Can I optimize by base image? Why my base image has increased so much size? So I need to calculate the base images also, differences between the old base image and the new base image. And I'll be running my batch jobs, nightly jobs on the images which is in the registry, in my local registry, right? So that will help me out to understand that one, is there any security vulnerability on those base images? That should be part of your CI/CD pipeline. And after you run, if security gate is clean, if you're okay with all the security related rules which I put together, then you move to the testing stage. You pull your image, you start testing your application, then you start running your containers from dev to TST. That is how the CI/CD, you should be scan your images, and these are production. As I told, in production, you should be doing these things, not scanning, I mean to say production lifecycle. How do you take your application from dev to your test environment, from your beta environment, from your QA environment to the production? Until QA everything, scanning, testing of your images, validating your images, running all your tools for security vulnerability issues. You should be doing everything in the testing environment, not in the production. Once everything is clear, there is a gatekeeper, then you move your cluster wherever you are going to deploy into production. And these are a couple of slides. So what I always advise people to read about: Free Software Foundation, GNU Linux Foundation, the Linux related news about where you need to find the source of truth, where do you find actually, and security related things from the Docker itself and Docker internals. So you can use these URLs to learn more about the Linux kernel, more about the Docker internals, more about Docker upcomings, what are the latest features they get released. And that's the thing I want to close the session. And this one thing, obviously, I want to talk about something about DevOps Artisan, because that is what my engagement DevOps Artisan started, is because they have very well-versed professional training exercises, training labs, kind of things in terms of dedicated to DevOps. I rarely see in other environments where they just talk about how to use the tool rather than talking about why to use the tool and what kind of labs, what kind of exercises, or what kind of experiences the real people from a production environment get into the DevOps Artisan company and prepare those labs for you so that you can actually implement those things in your real production, because that comes with their experiences. Like my experience is more on production side. I share what is the best practices in Docker, not what other people say, because I have been bitten with the problems with the Docker or a Kubernetes or the container images or anything. Those are the problems which I share. That's more important to me rather than saying how to run and how to use the Docker in production. And these are the different DevOps related tools, DevOps related technologies, DevOps related products, which you can very well verse with. I have seen a couple of tutorials. They have been well written. Labs have been well presented for me. So I always recommend to people, one of the places to go and look for DevOps related trainings. This could be one of the best places to go for it. And these are the certifications, which I think Elena can share much more on this information. It's not one actually, it's the only one where I see people have built trainings as per the industry needs, as per what does the industry needs. So industry thinks about release, industry thinks about deployment, industry thinks about ops, industry thinks about automation, industry real production, security, monitor. So every certification tied up to a specific set of tools, specific set of technology, and deep dive into that particular technology, rather than saying holistic way, let's learn end to end, and we don't know where do we fit. So they divided these courses in those particular verticals so that it is always useful for you to look at where you fit in and where your gaps are and how do you address those gaps. And that's my last slide. Elena, you want to share something? Thank you for everybody's time. If anybody has any question, so I'm happy to answer any questions.
Thank you, Narendra. Yeah, I want to check if there are any questions from our virtual audience, but I can see there aren't. Well, I want to thank you all very much for being us today. Thank you, Narendra. You offered us valuable information and interesting and helpful experience. Whenever you have questions, a general email where you can write to us is askformore@devopsartisan.com, and the specialist will take care of your request and answer you. We also invite you to follow our website, devopsartisan.com, for those who want to consolidate their knowledge in DevOps and discover our associate and professional certification. For which actually we launch promotional packages for our students to get the entire benefit of attending our classes. Have a lovely evening and see you next time.